Hello, this is Tolbert's class, Physical Science. This is lesson number 4. Today's lesson, we're going to define isotopes, understand the relationship between mass number and isotopic number, discover what radioactivity is by defining it, practice, and learn how to write the isotopic symbol and use it to find the isotope. We're going to do the alpha beta practice problem as part of your assignment for this week. And of course, you'll be able to identify alpha, beta, and gamma radiation and the relationship between when we call it an alpha particle or beta particle, what exactly is it? So, various atoms from various elements are different. Isotopes are the same element with different numbers of neutrons. The mass number of the isotope tells you the number of protons plus the number of neutrons. So the mass number is going to tell you the combination of protons and neutrons. In radioactivity, you have something happening to the nucleus. The nucleus is getting lighter, so to speak, or something is changing in the nucleus. The only things that are in the nucleus, of course, are protons and neutrons. Almost all elements have one or more stable isotope. That's what they call these. Isotopes simply is the same element with a different number of stuff going on in the nucleus. Stable means it stays together. In this particular example, carbon-14 is radioactive because it has an unstable nucleus. In this drawing, you can look and tell what we have going on here. You've got 6 protons, 6 neutrons, and if it's balanced, it's going to have 6 electrons. The difference between carbon-12 and carbon-13 is, notice I have a different number of neutrons. I've got one more neutron. So that's why it's carbon-13, because 6 and 6 gives me 12, but 6 plus 7 gives me 13. And in the same way here. The isotopic symbol is just a way that we use to write these. X is called the unknown. So here you're looking at the isotopic symbol. X is an unknown element. A is going to be my atomic number. The atomic mass is the protons plus my neutrons. Z, or the atomic number, is the number of protons. And N is the number of neutrons, or minus Z gives me that N number, gives me the number of neutrons. So the isotopic symbol for carbon looks like this, 12 and 6. 12 represents protons and neutrons, just protons, symbol is C. Isotopes from some elements may have unstable nuclei. They will spontaneously naturally emit energy to become more stable. They are radioactive. Elements greater than the atomic number 84 are all radioactive. Radioactivity is a process it's a process an unstable nucleus emits one or more particles or energy to form in the form of electromagnetic radiation. Okay? In other words, the process of unstable nuclei emitting particles or energy. Nuclear radiation is charged particles or energy emitted by an unstable nucleus. In other words, charged particles being kicked out by an unstable nucleus. All right, here's how we write isotopes. These are some important factors. So this is the isotopic symbol for carbon. This happens to be carbon-14. Okay, carbon-14's atomic mass is 14, which means protons plus neutrons is giving you 14. The atomic atomic number for carbon has to be 6. Now, here's the important part. 6 protons gives you carbon. If you have one more proton, it's no longer going to be carbon. Okay? If you have one less proton, it's no longer going to be carbon. It will be another element. So, given here, the element number of the element is carbon. It's this particular isotope, the atomic mass is 14. The number of protons is 6. And the number of neutrons is, if I was to take that 6 away from the 14, it's going to give you 8. Or if you go like this here, if I was to subtract 14 minus 6 is going to give you 8. You're going to need your periodic table. This particular isotope looks like this. And I want you to figure out this. What you want to look for first is the number of protons in the nucleus. The number of protons in the nucleus is going to tell you that it's this element, selenium. Okay. So you begin thus, you can by writing, this is going to give us an isotope that we're going to find. So 58 gives you that. This one's atomic mass is 41, okay, 141. So if you take 141 and if you subtract 58 from it, it's going to give you a number of neutrons. So 141 minus 58. So here's how you do this. First, you write down the equation in its original elements on the left side and the products on the right. So this is my original element. This is my x to the az is simply my unknown. And here is a particle known as an alpha particle. The nucleus is changing by this alpha particle here. So this is simply symbols that represent, I don't know what this is. It can be blank. So in this particular case, if I'm looks like on the other side of my reaction here, I'm going to be getting a helium. So if I were to subtract 4 away from 217, and if I were to subtract 2 away from 89, so 89, 88, 87. My new element is going to have 87 protons. I'm going to subtract 4 from that. 217, 16, 15, 14, 213. So this new one will have 213 here. So if you're looking at this problem, you have one side of that arrow is called a reactant. The other side of that arrow is called the product. Remember, X, A, and Z is simply, these are the unknowns. Some of the things that I know I'm starting with this AC element, which has an atomic mass of 217 and its atomic number of 89. I'm going to kick out this 4 to this helium particle, which is an alpha particle. So I'm going to take 4 away from 217. I'm going to take 2 away from 89. And there's my new number. 217 minus 4 gives me 213. 89 minus 2 gives me 87. My new element is called francium. We are ready for the alpha-beta practice. A little more information. The first one here is an alpha particle. Alpha particles is when you emit or you take away from the nucleus, you're going to take away an alpha particle. You're going to take away 4 and 2. This one here, you're going to use it in the same way as I did above here. So if I have this TH here, thorium, and I take 234 minus 0, it gives me 234. If I take 9D minus 1, Okay, minus a minus 1, okay, minus a minus 1 is going to give me 92. So when you subtract a negative, it's like adding. So beta particle is like adding 1 to the nucleus. Thus, I have a new one there. And gamma rays are simply energy. Identical to helium nucleus is an alpha particle. 2 protons, 2 neutrons. Beta particle, beta radiation is where there's going to be, you're going to change up something. It's like magic. The neutron changes from a proton and emits an electron. This is what we call the weak force. In this example here, I've got carbon, and if it emits this electron over here, 14 minus 0 is 14. 16 minus a minus 1 gives us 7. Gamma emitters, nothing happens to the nucleus. It simply emits energy to be more stable. And this will be the last slide. Hopefully you'll see where this fits. Alpha particle, here's what happens. The mass number goes down by 4. Atomic number down by 2. Beta particles, the mass number stays the same. The atomic number goes up by 1. Atomic number up by 1. Gamma, it all stays positive. Okay? That ought to do it.